Our initial testing of non-invasive operator tracking focused on hand tracking using Leap Motion, a stereo camera-based hand tracking sensor. Sensor performed well in initial testing, however follow-up testing in the PCM lab revealed a few weaknesses, one of which is that it was designed to work in specific configurations which proved to be inconsistent with the PCM lab environment, including insufficient distance between hands and the working surface. However, Leap Motion demonstrates that in principle, camera-based solutions have potential, so we decided to evaluate camera solutions with more flexible software development kits. In order to evaluate the new technology, we focused on the simpler issue first by moving from hand tracking to posture tracking. The Intel RealSense camera was used with a posture monitor application and tested in the office and the PCM lab environments. The Intel RealSense SR300 is an infrared and RGB depth camera that requires Windows 10. The posture monitor application was developed by JTech Labs for office use. The app uses the depth camera to assess the user's posture quality over time. During the experiment, subjects were asked to alternate between good and bad ergonomic postures. The results table combines tests done in both office and PCM lab environments. From the table, it can be seen that the software is very good at detecting good posture with a very small number of false alerts. The system appears to be calibrated to have a high confidence that the operator is in a bad position when alerting the user. The app performed much better in the office setting than at the PCM lab workstation. This is most likely due to the software's reliance on facial recognition. Facial features of the subjects were obscured in the lab by personal protective equipment and workstation instruments. This led to the conclusion that the posture monitor software was not suitable for the PCM lab, however it might have application in office environments. The limitations in the experiment appear to be associated with software as opposed to the hardware, which shows potential.
In order to flag the physical strains caused by the tweezing actions, we wanted to track the tweezers without having a sensor uncomfortably close to the tweezers. For this purpose, we used an electromyographic sensor which measures the electrical activity of the selected muscle. It is composed of 3 electrodes, 2 to be placed along the selected muscle and 1 on the reference area. When tweezing, several muscles are exerted. However, for signal quality, we need to place the sensor on a muscle of the superficial layer. Once preparation is done, we are able to read the output voltage of the EMG sensor thanks to an Arduino board. When the subject is exerting the selected muscle, the spikes in muscle electrical activity can be seen on the output graph. The EMG sensor can be used to detect high activity of the monitored muscle. However, in the PCM lab, the movements of the operator arm are not simple tweezes, and the monitored muscle is exerted in a lot of different ways. Therefore, additional data would be needed to lead to a proper movement identification.
Force-sensitive resistors in sensorized glove prototype have demonstrated very good capability to measure applied pressure. However, it was not perfect for the follow-up experiment. As part of initial work of the force measurement experiment, we have designed and built prototype of simple sensorized tweezers. We have mounted 2 force-sensitive resistors on the contact areas where the fingers are applying pressure during tweezing. These sensors allow to capture changing force during the usage of the tweezers. Signal is amplified and pre-processed using circuitry based on operational amplifiers and analog to digital data converter. Data is captured using a development board and stored for the further analysis. Initial data captured in PCM lab shows potential capability of tweezing action signature identification, which could possibly be used for break time suggestions, operator skill level, or operator fatigue determination.